All right, let's go ahead and get started. I'd like to start off by congratulating everybody for making it to the final day of reInvent. And today we're going to be discussing how to manage inventory, patching, and system images for your hybrid cloud environment with AWS management capabilities. My name is Taylor Anderson. I'm a product manager with EC2. And joining me today is Amjad Hussain, who's a senior manager also with EC2. All right, so what should you expect? What should you look to get out of today's session? Well, by the end of the session or during today, you'll learn how to automate AMI building and deployment. You'll also learn how to monitor your fleet configuration and gather software inventory. And then finally, you'll also be able to ensure that your instances are patch compliant. So in creating these capabilities, all these were really driven off of customer feedback and customer pain point that related to managing large number of instances in a hybrid cloud environment. More specifically, we heard from customers that managing cloud and hybrid environments using traditional tools can be really quite complex and costly, and there were 4 key areas for supporting that. One of which being that traditional IT tools really were not necessarily built for the cloud. So if you're an organization started off on-prem using a set of tools for management, and now you're expanding into the cloud, if you're using those same management tools, they aren't always a great fit for that cloud environment, particularly when you're working with the cloud with the elasticity that comes particularly with AWS, where you can change the amount of resources that you need on demand. Also, we heard universally that customers wanted a better visibility, better picture into the state of the instances that they were running. And then finally, we also heard that for a number of customers, they may have created really what was a best-of-breed solution using management tools from different vendors, but that created their own complexities, specifically when it comes to licensing. So, yesterday, during Werner's keynote, you may have heard that we announced Amazon EC2 Systems Manager, and we also discussed the capabilities within Systems Manager yesterday in a couple of presentations. What is Systems Manager? It's really a set of capabilities that enable automated configuration and ongoing management of systems at scale across all of your Windows and Linux workloads, regardless of whether those instances are running on-premise or in EC2. All right, so let's look at the specific capabilities within Systems Manager, and I'm just going to throw them all up here on the screen and then talk through them. And so in the leftmost column, 2 of these capabilities relate to configuration and administration. So the first one being run command. How many folks here have heard of run command? Okay, pretty good number of people. We launched run command in October of last year. Run command allows you to execute commands remotely at scale. The rest of the capabilities here were released as part of Systems Manager yesterday, which include State Manager, which allows you to persist a state or consistently apply a state or a configuration to an instance, specifically allowing you to deal with things like configuration drift. In the middle column, we have 2 more capabilities, which we're calling shared capabilities. These are resources that can actually be used by the other capabilities within Systems Manager. So for example, maintenance windows allow you to schedule and manage what are otherwise disruptive activities. For example, patching. So with maintenance windows, you can define a schedule, you can define a cutoff time within that period, that maintenance window, and then you can also define the actual tasks or activities that you would like the maintenance window to execute. Another shared capability is parameter store. So if you have usernames, passwords, connection strings, other attributes that you want to manage and optionally even encrypt using your own KMS keys, and then manage access to those parameters on a granular basis as far as other users, then parameter store is a great fit for you. So for example, you may want to use parameters when you execute a run command, or if you want to use parameters when you're executing automation, which takes us to the final category of capabilities here, and really the focus of this talk this morning. So today we're going to talk about automation, and more specifically our initial primary use case, which is AMI building or Amazon Machine Image building or creation. We're also going to talk about how to collect inventory from all your instances. And then finally, the last topic will be Patch Manager. So this is really the suite of capabilities within System Manager today. If you caught Amjad's presentation yesterday, he touched on Run Command, State Manager, and Parameter Store. All right, so let's go ahead and jump into automation here. Okay, so when we reached out to customers to identify pain points and is also understand what areas would really be great for an automation solution, we heard that the task of building AMIs, there was certainly some pain there. It's a task that goes on for a lot of folks at a fairly regular cadence, and there are several different triggers. So for example, Amazon releases new AMIs fairly regularly, and for Windows they're released on a monthly basis. A lot of customers out there actually take those stock EC2 AMIs and then harden them or customize them. But that's a monthly event, so that's a monthly update cycle. Other customers actually have taken ownership of their AMIs and have taken ownership of the patching. So we do that in Amazon EC2 of the AMIs we produce, but some customers have actually taken that ownership themselves. And so now they're patching their own AMIs, and that can be triggered if it's a Windows AMI. That's going to be a monthly cadence following Patch Tuesday. While other customers prefer to bake applications into the AMI, which gives them a much faster start time when they're launching, especially from auto-scaling groups. And of course, applications are changing. So these are regular automation build cycles. How many people here actually are regularly building their own machine images? Okay, a lot of folks. Okay, so I would assume some of you feel the pain here. So kind of a never-ending process. So we saw there was a huge opportunity here to really simplify this regular occurrence and build automation around it. And so, of course, we're introducing automation today, and one of the first things we wanted to do is make the service very easy to use with a shallow learning curve. So within a short amount of time, you'll be able to actually take a source AMI, customize it in some fashion, and then create a new AMI out of that. We're going to go through an example today of how you can do that using automation. You don't necessarily have to use automation exclusively for AMI creation, but that certainly is a big use case for it. And one of the nice things about how we've built automation is that it provides proactive event notification for every one of your automation steps. That was another big customer feedback point, is that I want to know immediately if I run into an automation step that is not successful. And of course, being an AWS service, it's optimized to work with a variety of other services, including Run Command, Lambda, CloudTrail, IAM, and CloudWatch events. So you may ask yourself, okay, well this sounds cool. How do I get started? 3 core steps here. The first one is to create an automation document. The second is to actually run that automation or execute that document. And then the third is to actually monitor your automation. So let's jump in and look at what that looks like here. I'm going to jump over to my demo machine here. And I'm going to switch over. Okay, so now I'm in the EC2 console, and here's the left nav, and you can see as of yesterday, we've added several new elements on the left, one of which has been around for a while is actually documents. So the first thing I'm going to do is I'm going to create an automation document. And by the way, everything that I show here in the console, of course, is supported on the CLI or through SDKs as well. So I'm going to create the document by pressing the Create Document button. And I'm going to call this Patch Windows AMI. And I have a choice of document types now. As you can imagine, we're going to select an automation document. And I'm going to go ahead and paste in a JSON object. So this is something I grabbed before the presentation. But this is basically a JSON document that comes directly out of the walkthrough in our tech docs online. So I'm basically going to follow the walkthrough that you can follow online. I'm going to run down. I'm going to click Create Document. All right, my document's been created. Great. So let's go ahead. I'm going to go to, I'm going to filter by documents owned by me. And there's my Patch Windows AMI document. And let's check that out a little bit here. Here's the description. All right, so Systems Manager Automation Demo. We're going to patch and create. And I'm going to click on Parameters here. So we can see that the way this document has been created, we're actually passing in 2 parameters. The first of which is the source AMI ID, okay? What are we going to start off? What are we going to launch this instance with? And then the second parameter is what we're going to call the new AMI that we generate from this automation process. So here are the types. It's going to be a string, and then the description, AMI to patch, as we just discussed. And then the second one is going to be the name of the new AMI. Now, I got a little fancy for this demo here. I could have just put in hard-coded strings for things like the source AMI ID, but I wanted to show a couple of cool features within automation. So if we look at this first element here, we can see that we have a delimiter SSM. So what we're doing here is we're actually pulling a parameter from parameter store, okay? So the actual value for the source AMI ID, say AMI 123456, that's actually defined over in parameter store. For the second item here, what I've done is I've concatenated two items here. So the first is the actual patched AMI, so that's what we're going to call it. And then the second half of the name of the new AMI will actually be a timestamp, okay? So we're using a global variable from the automation service itself. If we want to, we can go ahead and actually browse the document right here. So we'll see some of the things we just mentioned. Here's our description. Here's the assume role here. So what we did here is we created a service role that gives automation the authority to execute actions in our account here. So that's the role we're providing. Here are the parameters we just talked about: source AMI ID, target AMI ID name, and then here we get into the meat of the workflow here. So here are the main steps. And the first step here is going to be to start instance, and we're calling one of the defined action types that's supported with automation, which is run instance. And you can see we've got some flow control elements here. So our timeout in seconds is going to be 1200. That's the maximum amount of time we're going to wait for this step to complete. We're going to have a maximum number of attempts of 1. And also what happens if we do have a step failure here. So in this case here, we're going to abort and quit the entire workflow. So some other steps here we have. Here's really the core of the automation workflow: install missing Windows updates. And that's going to be based on run command. So this is actually going to execute a run command document called install missing Windows updates. And then we're going to stop the instance, create the image, and then terminate the instance. So let's go ahead and actually execute this document. So we do that by going over to the automation section in the console here. You can see I've run several automation executions previously. And I'm going to go ahead and do run automation. And here's my patch Windows AMI document. And I'm going to select version 1. So we do support versioning with Systems Manager documents. So if I'm doing a lot of iterating, I can pick whatever version I want to execute. And you can see here are the parameters, and here are the default values pre-populated. So I'm just going to click Run Automation, and our automation is started. So I can go ahead and click on that new automation workflow here, and we can see all the metadata associated with it. Where it really gets interesting is if we click on steps. Okay, so here are the steps that we just saw in the JSON itself. Let me move over the column here just a little bit. Uh-oh, there we go. There we go. All right. So we can see here that we have 5 steps in this workflow. First one is going to be start instances. Again, install missing Windows updates, stop instance, create image, and terminate. And so what I'm going to do, a little bit like a cooking show here, is I'm going to jump to a completed workflow to see what that looks like here. Here's an example of execution I ran before the presentation today. And I can go ahead and click on any one of these steps and look at the output. So for example, the output for the very first step here of launching the instance was the instance ID that I created. So let me go ahead and close that out. This second step here, again, is a run command execution. And so if I click on that, I'm actually going to see the output of run command here. And so we can see that since we are executing a document called install missing Windows updates, we can see here in summary that we installed 2 important updates, okay? So let me go ahead and close this out, close. And then one of the other items here is, again, I mentioned we can define outputs for our workflow. So here if I click on output, we can see that the output for this workflow is the ID of the new AMI that was created. Okay, I'm going to jump out of the demo here and go back to the presentation and just kind of highlight a couple of concepts that we just had in that demo. So again, for automation documents, you can define input parameters and output parameters. You can define defaults. And again, we support the ability for you to reference parameter store parameters as well as utilize system variables. For the automation steps that we currently support, the first 3 here are a lot like they sound, right? So run instances, change instance state, create AMI, fairly fundamental. The real power of automation comes from run command and invoke Lambda function. This is where you really have the ability to execute commands remotely, configure instances, or leverage the power of serverless computing. Going forward, we will be offering some public documents for your reference. Those will include AWS Update Windows AMI and AWS Update Linux AMI. Those will be more powerful versions of what we just saw today, which is also referenced in the technical documentation online. As far as setup for IAM, you do need to take a couple of steps to get automation up and working. You will need to create a service role like we saw in the document, and again, that role gives the automation service the ability to execute within your account. The one other item you're going to need to do is set up what's called a pass role for the user that's actually executing the automation. What pass role does is it gives that user the authority to provide the service role to automation. Finally, the last item here, if you do indeed use run command against any of the instances you launched, you want to go ahead and launch those instances with an SSM role, which you've likely been doing already if you've been using run command. And again, as far as monitoring is concerned, CloudWatch events, this was based on a lot of feedback we got from customers where, if I have automation flow and it breaks halfway through and I come back to my desk 2 hours later, I really wish I'd known immediately that something went wrong. And so with our CloudWatch events integration here, you can set it up so that you can get a notification for each step in that automation flow, either success or fail. And then separately, you can also get a notification for the overall execution of the workflow. All right, let's move on to our second feature for today, which is inventory. Okay, so what do we hear from customers regarding inventory? We heard a lot, but we certainly heard consensus around the fact that it's important to have a crisp, accurate picture of the software inventory and configuration of your instances. And this is important for a number of reasons, including just maintaining a security posture, understanding what the patch level is on your instances, or even understanding how many copies of a particular software package you're using and measuring that against what you're licensed to use. And again, we also heard in a lot of cases, some of the legacy solutions out there aren't necessarily optimized for cloud and scalability, as well as a lot of those solutions may require self-hosting. And so there's a lot of interest in having a hosted service from AWS. All right, so announcing inventory. And again, this ties into several of the recurring themes around Systems Manager. This supports end-to-end inventory collection. So whether your instances are EC2 instances, or they're on-prem, or even Workspaces instances. That was a big request, to be able to track inventory on Workspaces. How many people are using Workspaces? Great, okay. So you can use this with Workspaces as well. Works for both Linux and Windows. And of course, supports a powerful query, which we're going to look at in the demo today. It also includes an extensible inventory schema. This was another big piece of feedback from customers is you really need to let us be able to collect whatever kind of inventory data we want from an instance, or really append any metadata that's important to us, whether it resides on that instance or not. So we included that capability as well. And finally, like everything else, inventory works with other AWS services. So we have a diagram here that kind of explains how inventory is gathered from instances. You'll see in the center of this diagram here, we have something called an AWS SSM service. So for those of you that work with CLI quite a bit, that's really the namespace for the services, particularly for run command. And so the way inventory works is we start off by creating effectively a document. Remember, we just looked at creating an automation document. Similarly, we'll create a document for inventory. And that document states what types of inventory we would like to collect from an instance. Do we want network information? Do we want application information? Do we want to know information about AWS components, et cetera? And then that document is actually sent out through what's called an association. So if you were in State Manager with Amjad yesterday, you heard about associations. Basically what we do is we select the type of inventory we want to collect. We select the target instances we would like to collect inventory from. And then we select the update frequency that we would like to gather that information. Do we want it once an hour? Do we want it once a week? So that document gets pushed out to these various instances here, and that's effectively handled by the SSM agent. So we have one agent that's used for all the System Manager capabilities, and that agent then responds back with inventory detail. The agent behaves in a very lightweight, very efficient fashion, and really only reports diffs going forward over time. So there's a very, very small amount of information that goes back to the store, and then that represents a snapshot, a point-in-time picture of the inventory across your instances. Now, another piece of feedback we got from customers is, yes, I want a point-in-time snapshot of the inventory in my instances, but I also want a historical record. I want to know how things change over time. And so this is why we built an integration with AWS Config. Any AWS Config users out there? Great, okay. So if you're using AWS Config, you can optionally select inventory as yet another resource type to track over time. The beauty about AWS Config is that you can go back historically. It's kind of like a tape recorder for a resource type. You can go back in time and see what happened when. And you can also optionally set up what are called config rules that proactively notify you based on some kind of state that doesn't match your intended state. All right, so how do we get started with inventory? This probably looks similar to how we get started with automation. The first step is we configure an inventory policy, okay? And then next, we're going to apply the inventory policy. And finally, the fun part is querying inventory. So let's jump back into a demo here. Let me get all set up on the demo machine. And switch over to 3. Okay. So what I've done, and we space things out a little bit here, is we're in the Managed Instances view, which is kind of like the dashboard for Systems Manager. And what I'm going to do is I'm going to set up to collect inventory from an instance. I'm already collecting inventory from several other instances. So we've got this great button here. We tried to make this as intuitive as possible, called Setup Inventory. So we're going to click Setup Inventory. And we're going to scroll down, and the first selection we have is to select the targets or instances we would like to collect inventory from. And we can do that either by using a tag or by specifying the instances individually. Using tags is really quite powerful because even if we were to set up this association now and begin collecting inventory from instances, next week, if I launch a new instance with the tag I've referenced here, sometime in the future, then that instance will also start reporting inventory automatically. For the sake of our demo today, I'm going to go ahead and use an individual instance. I'm going to set up inventory collection from an instance I'm calling WS 2016. And my schedule I'm going to set up to be every 30 minutes. And then at the end here, we have a variety of parameters. So these parameters represent the different inventory types I can collect. So I'm going to collect applications, AWS components. I'm also going to gather the network configuration detail. This is a Windows instance, so Windows updates. And then a final item called custom inventory, which we're going to go into a bit more detail in a second. All right, so that looks good. I can optionally have the results written to S3 if I want, and I'm going to click Setup Inventory. So that's going to take about 5 minutes to get going. So I'm going to fast forward to some other instances that have already been reporting inventory. So let's go ahead and look at those. So I'm going to jump down. I'm going to click on this instance called AWS Linux. And here we go again. And I'm going to click on Inventory. And I can see I have some inventory data here. So here are dictionary quit. That's OK, because I don't need the dictionary. All right, so I have different inventory types I can filter by. Right now I'm filtering by application. So let's say I want to know if this instance is running Python or not. I can go in here. I can select the application name, and I can say begins with, and I'm going to type in PY, and I can see, in fact, that this instance is running Python 2.7. So right now I'm doing searches at the instance level. I decided I wanted to have a little bit of fun here today to illustrate custom information. And so before the session here, where did I put it? I must be on the wrong instance. OK, so I'm going to keep moving here. I'm going to scroll down to my next instance here, which I haven't labeled, but this instance happens to be, I'm sorry, you know what? I need to clear out my filter. There we go. All right, thank you. I've now cleared the filter. I was filtering by Python earlier. So in this case here, I'm looking at an instance that is a workspaces instance. Okay, so now I'm looking at the application on that workspaces instance. The way I set it up is I used an activation. So the same process by which I would activate an on-premise instance, I used to activate this workspaces instance. I'm going to go back to my Linux instance here and see if I can filter by other inventory types here and see if I can pull up speaker rating. Okay, there it is. So this is an example here with speaker rating. I decided to have a little fun and just create an arbitrary inventory attribute here. And the way that I did this is I basically used the put inventory API, and I uploaded a JSON object. In this case here, I gave Amjad and myself a speaker rating. So rated this as the best session ever with a rating of excellence. So I hope you agree. Yeah, there we go, thanks. All right, so let's keep searching here and expand our query beyond just the instance level to all of the instances that are in our managed instance list here. So I'm going to unclick this, and I'm going to go up here, and I'm going to do a search by name for all instances, let's say, that have, I don't know, Microsoft.net on them. Okay, so it turns out that 3 of my instances have Microsoft.net on them. And if I wanted to, I could go ahead and click on any one of those. But let's say my organization has decided that we wanted to move Microsoft.net, we want to standardize on 4.6. So we want to go out and find all instances that are running something less than 4.6. So I can continue to build out my query here, and I can jump into, well, application version, and I want to see all instances that are less than 4.6. And I'm going to run my query. It turns out it's the same lot of instances. So let's go ahead and click on one of these instances. And I'm going to go to the application view here. Excuse me. And I'm going to scroll down, and I can see, yes, here it is. Microsoft.NET Framework is running 4.5. So effectively what we've done is we've used inventory to go out and identify a set of instances that need some form of remediation. And then the ensuing step would be for us to go ahead and use run command. We could use the update application document, or we could use state manager to go ahead and bump these to 4.6. One other thing I'd like to show really quickly here, and I'm struggling. Please hold your MacBook jokes. I'm going to go back to my Linux instance here. Over in the right-hand column is a cool icon, which is our AWS config timeline icon. So I'm going to go ahead and click on that. And this is going to take me over to AWS config. And we had some folks who are using this right now. The reason we're looking at AWS config is because we're interested in historical record of what's happened to this instance here. And remember, we're feeding AWS config inventory data. So we can see on November 22nd, there were actually 7 changes to this instance that related to inventory. So if I click on those, I can actually see on this date, I happen to install MySQL and Nginx on this instance here. So not only do we have a snapshot point in time when it comes to inventory, but we can also look at a historical record as well. All right, I'm going to jump back into the presentation here. Grab my clicker. Okay, so just to summarize what we saw in the demo here, we want to create an inventory association, 3 core elements. We've got to select our targets. We're going to select the frequency that we would like to gather inventory at. And then finally, the inventory types, including applications, AWS components, network configuration, Windows updates, and custom inventory. And again, when it comes to custom inventory, you can record whatever you want, whether these are attributes that are on the instance that you would like to extract, things like BIOS or firewall settings, or if there are things that you've been maintaining in a spreadsheet. So for example, if you have on-premise instances and you've been maintaining rack location or in-service data or whatever, you can also push those to the inventory store. So the 2 methods for adding items to inventory either include directly from the instance itself. What's going to happen is that the agent is going to look in a predefined directory. It's going to look in a specific path. It's going to look for JSON files there. And if it finds them, it's going to upload them to the inventory records for that instance. So the way you could do that, for example, is you could write some kind of scheduled task or a cron job. If these are attributes that are changing, that would continuously update those JSON files in that directory, and that's then going to get passed on by the agent to the inventory store. Alternately, if you want to, you can use the put inventory API to go ahead and upload that detail as well. Queries we just looked at, you can query by inventory attribute, you can do partial and inverse searches, and you can do more elaborate filters if you want to. You can string them together. So for example, if you wanted to look for all instances running Windows 2012 R2 that also featured SQL Server 2016 that were missing a particular Windows update key 112342, you could actually build out a filter like that and then identify instances that needed some form of remediation. And then finally, to summarize, when it comes to our integration with AWS Config, allowing you to record inventory changes over time, you can use AWS Config rules to monitor changes and proactively notify you, really helping you to meet compliance and government mandates. All right, with that, I'm going to turn it over to Amjad Hussain to cover Patch Manager.
Thank you. Thank you, Taylor. Just give me 1 second. All right, so Taylor walked us through automation and inventory. And you saw how you can use some of these new capabilities in Systems Manager to automate your AMI creation or AMI build-out process. And you can use inventory to collect software information and do querying and all that kind of stuff. The thing I wanted to spend some time on was Patch Manager, and specifically Windows patching. So one of the things that, we talk to a lot of customers who are using Windows workloads and Windows Enterprise workloads, and one of the common themes that we keep hearing is that patching Windows at scale is, is a manual process. It's error-prone, and and it's a critical part, right? Because getting security updates on time is a key part of keeping your instances and your fleet in a healthy state. So, like I said, not just from a security perspective, but from a compliance and compliance and downtime perspective, having systems be patched is important. And that is why we are announcing, as part of Systems Manager, Patch Manager. With Patch Manager, what you can do is you can simplify end-to-end patching of your Windows instances. It's easy to automate because it uses a lot of the same building blocks that we've been talking about so far in terms of Systems Manager. And just like inventory and automation and run command and state manager, Patch Manager is also integrated with other AWS services, CloudTrail, CloudWatch events, and things that we've talked about in the past. One sort of point of clarification. So far, everything we've talked about works on Windows and Linux. Run command, inventory, automation. The Patch Manager itself is a Windows-only release. This is our first release, and we're going to focus on Windows. However, it does work across EC2 and on-prem instances. So that's Patch Manager introduction. To get started, you can sort of mentally break it down into 3 phases, if you will. The first thing you want to do is you create a patch baseline. And really the thinking behind a baseline is that it's how you get to define your selection criteria, right? So you figure out what are the patches that you want in this baseline. Once you've created baseline or baselines, what you can then do is you can use maintenance window, which we'll talk about in a bit, to schedule the patching on a regular or on some cadence that you want to patch your systems in. And then once you have scheduled the baseline with a maintenance window, the last step is to actually execute and then view the results. And that's where we have the patch compliance set of APIs that will let you view the results of your patching. So for example, using patch compliance, you can do things like what percentage or how many instances from my fleet do not have this, are not in compliance with this baseline. So that's a quick introduction on how do you get started with Patch Manager. The next slide, it's just a more sort of a UI way of representing the same information. Really, you start out with a baseline. So on the top of the slide, there's a baseline. And you can see here I'm saying include everything that is critical or high priority from a classification, from a patch classification perspective. And then you can also do a time-based filter, because sometimes you might want patches that have already been out there for a while. So you can say only pick up patches that meet that criteria after they've been published for 5 days. So that's a baseline. The next step is scheduling. the action or the task in a maintenance window. Maintenance window, as you'd expect, is essentially a recurring schedule. So you can say every Sunday or every Saturday between 12 to 3 a.m. I want to schedule my patches, and you get to define how long that duration is, as well as how long after the duration starts or that time period starts, do you want to stop scheduling more actions. So that's a maintenance window. And then the last part, like I said before, is the compliance, where you can get this sort of consolidated view around how many instances are up to date, how many are missing patches, and what are the specific instances that are missing, so that you can take remediation steps, such as maybe taking it out of load balancer or something else. Okay, so let's spend a little more time going into the details of each of these concepts, a baseline, a maintenance window, and the compliance side of things. So with a baseline, like I said before, essentially a rules criteria. So you can do things like, this is only applicable for Windows Server 2012 R2. And the classification is critical or severe, or whatever the classification that you want. And there's a time approval process. So some companies and some customers that we talk to say that, look, sometimes you want to vet or test the stability of a patch before we actually roll it out, especially to our production servers. So you could have a baseline that says something like, wait 15 days or 30 days after. Would that be too long? But yeah, you can pick some time period after it's been published to have it included in the baseline. So that's your selection criteria. You also have explicit approve or reject lists. So you can say that these are my rules, but then in addition to that, I want to make sure that this specific KB or this specific list of patches are always included. Similarly, if there is a patch that you know does not work or you have not tested the compatibility of, you can reject it. So that's the reject or disallow list, if you will. And the last thing is that you have to register, or you have to tell us what groups of instances are part of that baseline. And the way you do that is something called a patch group. And a patch group is simply a tag with the key equals patch group, right? So using this sort of grouping mechanism, what you can do is you can prepare your instances, and everything that has a key equals patch group, you can give it a specific value, like my database servers or my web servers or my pre-prod environment or something like that. And that's it. Once you get this set up, you can basically create a bunch of baselines partitioned by your fleet. So you can have a pre-prod and a web server and a backend, for example, and you can have specific rules and filtering criteria that are defined and captured in the baseline. Let's spend some time on maintenance window. The first thing I want to talk about maintenance window is it's actually a generic concept. It is heavily used by Patch Manager, but maintenance window, like Taylor was saying at the beginning of the talk, is a shared capability across Systems Manager. So you can certainly use it for in the context of patching, but you can also use it in the context of any other repeatable sort of task that you want to perform. And the way patching uses it is there is a predefined run command document called an AWS-apply patch baseline. And using this document, we trigger or we signal the fleet to say that, OK, please go ahead and update yourself. And here is the baseline, or here are the rules that you're going to follow to update yourself. So that's a maintenance window. We already covered this. The only new thing here is once you have set up your maintenance window, when the maintenance window period comes, the maintenance window service will schedule the action. In this case, it's going to apply the patches, and then it's going to report back that information back to the patching service, and then you can use the compliance APIs to view the results. Speaking of patch compliance, like I said before, it's a fleet-wide summary of your patch status, and there's a dashboard that shows the count of compliant and non-compliant instances. Okay, so let's get to a demo. Okay, so I have a mixture of both CLI and the console. Taylor already showed you some of the key aspects of the Systems Manager UI. What I'm going to focus more on are maintenance windows, and then we'll spend some time on some of the patch-related activities. So let's switch first to the CLI. All system manager APIs that we've talked about today as well as yesterday are in the SSM namespace. So the way you'd run a command is from the AWS CLI is you would just do AWS SSM and then the API name that you want to call. So in this case, I'm going to run a command or a CLI that says describe my maintenance windows. In this case, you can see I have already created a maintenance window. Its duration is 2 hours, and it stops 1 hour into the schedule. It has a window ID, so you can uniquely identify the maintenance window. It is currently set to enabled, and I have given it a friendly name. And here's an example of how from a CLI you'd actually create a maintenance window. You can see I gave it a name. There's a schedule which can be expressed as a cron expression or a rate expression. So in this case, I have selected a rate expression. So this maintenance window fires every 1 hour. There's a duration and cutoff like we talked about. And there is there's another parameter to let you create the maintenance window without a patch group or a group assigned to it. You can also update a maintenance window. So you can change its schedule or other attributes. And you can delete a maintenance window. Let's call this get maintenance window API. That's going to show us more details about the specifics of the maintenance window. Once you've created a maintenance window, that action or that act on its own doesn't actually do anything. It's just a schedule, and there's nothing that you've specified around what to do when that happens. So once you've created the maintenance window, you have to do 2 additional things. You have to register a task, and you have to register a target. So the way you do that is, you can see right here, I am calling register target with maintenance window. With this API, what I can do is I can give the maintenance window that I want a specific target so that it knows where does it need to perform that action. Once I've done that, I also have to register a specific task. The task is what to do. So using these 3 concepts, the maintenance window, the target, and the task, maintenance window now has all the information it needs to actually complete the binding. So every hour in this case, what it's going to do is it's going to call run command, if I'll show you right here. So you can see here, every hour I'm just going to call run PowerShell script, and I'm just going to run a simple ipconfig command. That's it. So let's look at the UI and see how it looks like now. So I already created the maintenance window that I just showed you. You can see it has a couple of tasks that I've registered, and it has a target. So it always binds to this, or targets this instance. Now if you look at the history, you'll see that ever since I created this maintenance window, every hour it has been running and executing the same command, right? Let's pick one of them. Once you drill down into the execution history of a particular run, you can then see what tasks were performed during that maintenance window. You can click on one of them, and you can see even more information. Like, in this case, because it was a run command action, it actually kicks you off to the run command console, where you can go ahead and get all sorts of information, like what exactly happened. In this case, I ran ipconfig, so it gives me that information. Okay. So that's a simple demo of how do you just get started with a maintenance window. The second thing I wanted to show you is how do I stitch all this together with patching, right? How do I bring the scenario together? And the way you do that is you start by creating a baseline. So right here, I'm going to create a simple baseline, and let's just walk through it just so we understand what we're doing here. We're creating a patch baseline, and I'm giving it a name, my important patches. And I'm giving it a bunch of approval rules. These are the selection criteria that we talked about before. And in this case, you can see that I want everything that is classified as important or critical, where the product is Windows Server 2012 R2, and I want to approve it after 5 days of the patch being published. And I give it some friendly description. And now I can go ahead and describe my patch baselines. So you can see here that Amazon publishes a default patch baseline, just so you can get started very quickly. And for the default patch baseline, we have a set of selection criteria that we've already picked for you, like critical and important and things like that. Once you've set up your baseline, or you are reusing our existing baseline, you can register the baseline with the maintenance window. And you do that by using the same way that I just showed you where I was running the ipconfig command. You run a command that says register task with maintenance window, give it the maintenance window, and you give it the patch baseline document. Remember the AWS patch baseline that we talked about. Once you've done that, you can do a describe call on the maintenance window task, and you will see what are the specifics of the maintenance window. So for example, let's just go through this. This maintenance window task has ipconfig, which we just set up, and it has another task registered, which is your patch baseline right here. So you can see I'm applying my patch baseline, and the target is the same instance that I'd selected before. And that's it. Once you do this, once you have a baseline, once you've set up your maintenance window, we're just going to go ahead and update your instances when the recurring schedule happens. To find out what the results were from a compliance perspective or a results perspective, you can use the patch compliance APIs that I talked about. So for example, let's run through a few of them. This one says describe instance patches. So for a given instance, tell me what are all the patches that were not applicable. So I can even do things like, were there any patches that I should have installed that I maybe missed because my rule selection criteria was not correctly tuned? So you can see here that yes, there were a bunch of patches on this instance that were deemed to be not applicable. Similarly, you can run another one that says, show me all the ones that were installed on this instance. And it'll actually show you all the specific updates that have been applied. And you can get more information on these as well. I can also run a query that says, what are all the patches that are missing? So you can do something like describe instance patches with filter as patches that are missing. In this case, you can see that I actually have a critical update that's missing on this instance. And then I can take some remediation steps like either update my baseline or use run command to do an ad hoc patch on that instance. And with that, we're almost done. Let me just switch back to the UI. And the last thing I wanted to show you was, if you look at the maintenance window history, and let's go back to one of the runs that we did. You remember how there were two of these, and I didn't actually go and expand this? Let's just go ahead and expand this, and you can see that right here it shows up, right? So for this maintenance window, I have registered both the run command action, which was just running an arbitrary PowerShell script, as well as my patch baseline. So with this, so just to recap, Patch Manager is an end-to-end automated way for you to patch your Windows instances. It uses a baseline concept that lets you define your rules and selection criteria. There's a reusable maintenance window that helps you schedule things. And then there's the compliance side of things where you can view and report on patches that are installed or missing. Patch Manager will be available soon. The rest of System Manager that we talked about is already GA, so you can use it, automation, inventory, run command, all that. Patch Manager for Windows is coming very soon. All right, so with that, thank you. And what we'll do is we will, people who have questions or want to have deeper discussions, just come on over. We have another person from the product team as well. So we'll be happy to get feedback and have deeper discussions. Thank you.